Take-home quiz. Oh, it's way too loud. Here we go. And Circuit. Number 1, how much momentum? So momentum, 1 mark, is mass times velocity. So it's going to be 80 times 22. 80 times 20 would be 160. No, 80 times 20 would be 1,600. 80 times 2 would be 160. So it's going to be 1760? Yeah. Units. Kilogram meters per second, or Newton seconds, but since I went mass times velocity, I'll use that one. 1 mark. I'll even go all or nothing there. Just so tired, you got a little rusty thing for your chin there? That works. Sierra, what's A asking me to find for number 2? What's another word for change in momentum? So I could have said find the impulse. Anyways, I got a whole bunch of different ways. I scanned this. As soon as I saw initial and final, I said, aha, I'm going to find the change in momentum by going mv final minus mv initial. And the other thing I looked for was if there were any directional changes. But as near as I can tell, this is just going in a straight line. So I don't think I have a change in like a negative or anything like that. I think it's going to be 220 final 52 minus 220 initial 23, and I get you get 6,380 kilogram meters per second. Now, I didn't ask for a direction. Usually if I want the direction, I put magnitude and direction. Impulse, Emma, is technically a vector. There should be a direction. You know what? Positive, forward. He sped up. The biker sped up. Emma, what does B want me to find? Force. What did I find in part A? I got to be fussy, not the momentum. The change in impulse. Hey, I do have an equation for impulse that has force in it because I have my green sheet out in front of me, right? I think it's this one. Impulse is also force times time. So it seems to me, Emma, I can go like that. Now, F equals what? MA. Do you know M? Yeah? 220. David, do we know A? You could find A by going VF equals VI plus AT, A equals VF minus VI over T, and you could go F equals MA, and I will give you full marks. My point for the impulse equation has been, it's a nice shortcut because it combines a lot of stuff, especially if I know the impulse, because it's going to be 6,380 divided by 52. And I get 58, because I can't read. Oh, I got to retype that now. 6,380 divided by 58. And I get, you get 110? Wow, I even made these work out evenly for you? I normally don't care enough about you guys to do that. Oh, what's the units? Newtons, Mr. Duick. Newtons. 1 mark. Cool. Cole, what's 3A want me to find?
Impulse.
What's another word for impulse? Change in momentum. Okay. I think I'm going to use mv final minus mv initial. How do I know that? They gave me an initial velocity. See it? 18. What's my final velocity? Oh, okay. That's how I knew. I probably should have underlined the from rest. So it's going to be 0 minus 80 times 18. 80 times 10 is 800. 80 times 8 is 864? Negative 864? Am I totally wrong? Am I wrong? I'm wrong? Wow, I was totally off. I forgot to carry a 0. Duick, negative 1440. I'm going to be insistent on the negative. Or, if you wanted to assign that a direction, what would you say? Backwards. You know what? He has to lose momentum to come to a stop. That's really what we're saying. Otherwise, how is he going to stop? Cool. Christy, what's B want me to find? Now, F equals what MA, and there is a force. You could find time without impulse. But the fact that I happen to know that impulse equals force times time, it's force times delta t, but you can see I flip-flop and I'm lazy because time is always a changing, and sometimes I stick it there and sometimes I don't. Point being, Christy, how would I get the t by itself? Divide what?
Divide F.
Yes. I've never written time this way, but apparently it's going to work. Has to work. The physics is sound. So you're telling me time is the impulse divided by the force, and the impulse was negative 1440, and the force was 270, and time is going to be in seconds, and it's a scalar. Why do I get a negative time here? What subtle error have I made? Yeah. Why? Oh, yeah, because the force is in the same direction as the impulse. I should have made the force negative. Now, Rihanna, if you got this, and then you said, well, I know time's a scalar. I did something wonky, but I know time's a scalar, and you just said the answer was 5.3, I will give you, or 5.33, I will give you full credit for that. But really, I should have realized by looking at the negative time, I've done something wonky. Misha says, oh yeah, I should have called the force negative as well. And again, one of the things I've tried to teach you, Brian, is don't trust your calculator. Always interpret it. You'll often catch subtle errors by interpreting what your calculator is telling you, right? Right. Turn the page. If it sounds like this is repetitive, impulse is repetitive, but in different ways. Nick, what's A asking me to find on the back page? Impulse. Oh! That's change in momentum. You know what? I see a velocity. I see a velocity. What else should I notice if I was clever? What else do you see here? They're meters per second. I'm good with that. I think you're right, but your lips are hiding behind your water bottle. What did you say? The direction. Okay. What do you want to let be positive? What do you want to let be negative? Pick. Okay, here's what I would actually do then, because you know I like to be as organized as possible, but little writing as possible. I would probably do something like this. Positive above the word east, positive there, negative above the word west, and I would stick a minus in front of anything that was west. You can do that later as you insert the numbers, but I like to do it right when I notice it, Brian, so I don't forget later, because it's not like that ever happens. I think I'm going to use the MV final minus MV initial. Yes, Nick? So it's going to be MV final minus MV initial. M 0.17, 170 grams. V final, negative 43 is what you called it, minus 0.17. V initial, 22. So I get 0.17 times negative 43 plus 0.17 times 22. I get negative 3.57. Is that correct as a magnitude? Is it 3.57? No? Yes? People nodding? No. I've seen one yes and one no. I've seen another yes. Otherwise, a whole bunch you haven't done the quiz. If that's the case, I'm a little choked. Did you get that? No?
You added.
Oh, I added. Thank you, Brian. I'm dumb. You're saying I should have done that. Do you get 11.05? Well, that works better. Thank you very much. 11.05. So, negative 11.05. What's that negative mean as a direction, Nick? Yep. So if you said that, I'm okay with that. Or if you said 11.05 kilogram meters per second, west. Now, it's possible that Brian chose to let west be positive and east be negative. You would have just gotten a positive answer at the end of yours and still called it west, but it still would have been 11.05, assuming you didn't foolishly add them together like I did for some dumb reason there. 2 marks. 1 mark. Half mark for the numbers. Actually, you know what? I would probably do something like this. Half mark for the magnitude and a half mark for the direction. Brian, what's B want me to find? I could probably use F equals MA, and I could probably find A. What did I find in part A? You know what? I think I can say force equals impulse over time. It's going to be 11.05 divided by 0.025. It's going to be this number divided by 0.025. What's the negative telling me? In my case, also as a direction, west. Yes? Is it 442 newtons? Hey. I would give you 1 mark for the equation, half mark for the magnitude, half mark for the direction. 2 more, we're done. Once again, it wants me to find the impulse. Okay. You know what? I think this time I'm going to use force times time. Partly because, Oliver, what's part B asking me to find? Well, then I can't use V final to find impulse if I don't know V final. Did they give me a force? Yeah. Did they give me a time? Yeah. Have I made a mistake? Yeah. It's a very subtle one. So, as a magnitude, I think I get 15.3. Is that correct? What's my subtle mistake? So we're talking about a baseball. I'm going to make the assumption all of you, either live or on TV, have seen a baseball getting hit. When a baseball gets hit, what happens to its direction? It changes. I should be taking that into account. So, I'll let east be positive. Rebounds do what? Negative. What direction is the force? If the baseball comes in east and heads out west, what direction must the force be? I should have called this negative, and that would give me negative 15.3 or 15.3 Newton seconds. You could also say kilogram meters per second, but here's the important part. What's the direction? West. I'll take a half mark off if you didn't put a direction there. Dylan, what's B want me to find? Force, well, you know what? Impulse equals mv final minus mv initial. I guess I can plus this to that side and divide by m. I'll get v final equals my impulse plus mv initial divided by m. It equals my impulse, which is negative 15.3 plus 0.15 positive 39 divided by 0.15. Negative 15.3 plus 0.15 times 39 divided by 0.15. Negative 63. Is that right, Mr. Dewick? Did I type this in wrong? Oh, final velocity should be west. Yeah. I thought I was finding initial for a second there and going, what? So I get negative 63, which is 63 meters per second west. No? No, yeah? I would give you 1 mark if I saw that. I would give you, actually, I would probably give you 1 whole mark if I saw that. I would give you a half mark for the magnitude and a half mark for the direction. And can you give yourself a lovely score out of 13? Chloe, can you read me the title of this lesson, kiddo? What does C of M stand for? Do you remember? Conservation momentum. Okay. First, we're going to go off on a tiny bit of a tangent. I've been talking about crumple zones and how the key to minimizing injury in a car accident is to increase the time of collision. Because if you increase time, what does that lower in our impulse equation? Do you remember? Force. Good. Which lowers the acceleration, and it's the acceleration that does the damage to people. How does this work in a smart car? Because you haven't got a lot of crumple zone. No, what was your question? What did you say? The smart cars, there's some neat engineering. They actually designed the engine itself to be the crumple zone because it's got to go somewhere. Put your pencils down, look up. There's physics everywhere, even when you're in the bathroom. You may have noticed in the bathrooms, they have these massive toilet paper rolls, especially in public washrooms, the big long ones. And you may have noticed, and if not, you can try and notice them the next time, especially when there's a lot of paper on the roll. If you tug very slowly and gently, the roll will unwind. But if you yank it, the paper will break. Why? Why would it break sometimes? Why would the paper not be strong enough to move the roll sometimes, but also be strong enough to move the roll sometimes? What's going on there? Put your pencils down, look up. Some terminology. I will typically use this term. These are 2 terms you need to know. There are 2 main types of collisions. There are collisions where the objects bounce off of each other, and there are collisions where the objects stick together. Examples of collisions where the objects bounce off of each other: curling rocks, playing pool, billiards, a baseball and a bat. I have yet to see a baseball stick to the bat. Some car crashes, not all car crashes. Some car crashes, the cars bounce off of each other. Some car crashes, they stick together. There's a fancy word for bounces off of each other, and we call that elastic. If a collision is elastic, they bounced apart. And I always remember that because I think the word elastic, that's like a rubber band which bounce apart. The second main type of collision, Hannah, is where they stick together after the collision. For example, a football player tackling and holding on to the ball carrier. A dart hitting a dartboard. Some car crashes. A bullet entering and sticking inside the target without going all the way through. We have a fancy word for that. Call it inelastic. Not elastic. I will often, Emma, in my description of a collision, say to you, assume the collision is elastic or assume the collision is inelastic. What I've just told you is, after the collision, what's moving? Car 1, car 2, both or neither, stuck together or separate. Put your pencils down, look up. Done, pick your pencil up. Here's the kind of questions I'm going to throw at you at a test. Okay? A car traveling 44 meters per second collides head-on with a car traveling 22. You know what? I'm going to underline in the opposite direction. What does that mean? I'm going to have to do let one way be and one way be. What do you want? Mateo, decide. Do you want the first car going positive or the second car? The 44 positive or the 22 positive? Pick. So let's put a plus right here to notice that we caught that. Let's put a minus there. Okay. Then, is there a collision? Mateo, is there a collision? This is a job for conservation of momentum. This is what we did last day. So we started out by saying the total momentum you start with has to equal the total momentum you end with. Mateo, I want to be organized. I also want to be lazy. You know what I'm going to call the first car? Car A. How am I going to show that? Look up. A. B. I'll write the letters M right above the masses. You can go fancier than that, but I think, Christy, that's enough for me to figure out what I'm doing. Mateo, before the collision, what's moving? Car A, car B, both or neither? Stuck together before the collision or separate? So I'm going to have car A's momentum initially and car B's momentum initially. Wham! They collide. After the collision, Mateo, my friend, what's moving? Car A, car B, both or neither? Stuck together or separate? Is this collision elastic or inelastic? Inelastic. Now, there's a bit of a problem here because if I say it's an elastic collision, that sounds like I said inelastic because the word elastic has an AN in front of it when you say an elastic collision. So you're going to hear me always exaggerate. I'll say it's an elastic collision. I'll put a big pause there. Or I'll say it's an inelastic collision to try and emphasize it as best I can. Anyways, so stuck together, momentum, both. Final. Emma, momentum is what times what? Mass times? Good. So car A is going to be mass A, velocity A, and this is initial, yes? Car B is going to be mass B, velocity B, and this is initial. And then I guess both is going to be in brackets A plus B, V final. Mateo, what are they asking me to find?
Velocity.
Which one? Yep. Look up. How do I get the V final by itself? By the bracket. Like again, you can, I guess, write that equation. Oh, please don't. I'm teaching you how to derive all these because I just cannot come up with every possible scenario and equation out there. I'm not going to. The equation that we wrote down on your formula sheet, I put that one on there, right? The law of conservation of momentum. So you're telling me, and you're correct, Mateo, that if I want to find the final velocity, it's going to be the mass of car A, velocity of car A initial, and the mass of car B, velocity of car B initial, all divided by both masses. Have I got room? Oh, I got lots of room. You would be correct, sir. Let's crunch the numbers. Mateo, what's the mass of car A? I've scrolled down.
1.5.
I think that's 1,500, which is less writing, or you can write 1.5 times 10 to the 3. What's the velocity of car A?
44 meters.
Plus? What's the mass of car B? 1,000? What's the velocity of car B?
22 meters per second.
What?
Negative 22 meters.
Oh, I was going to freak for a second there. All divided by. Are you okay? Can I add these together in my head? 2,500? Now, if I get a positive answer, look up. Here's what happened. Here's car A and here's car B. If I get a positive answer, car A won and car B ended up going backwards. If I get a negative answer, car B won the collision and car A ended up going backwards. So for a direction, we'll finish by saying in the direction of car blank. What do you get for magnitude? Really? You weren't all typing while I was yakking away? Sierra was. Emily, usually you're quicker than that. 17 point? Anybody else? Yeah? Positive or negative? Positive? Okay. So I get positive 17.6 meters per second, which is going to be 17.6 meters per second in the direction of car. Which one, Mateo? Is that what we let be positive? Are you positive? There you go. What did you say? Is this collision elastic or inelastic? Thunk. Circle it. You can write it, but circle it. Okay. Now, in this question, I said the cars stuck together. What I'll start to do is simply say, assume the collision is inelastic, and you'll have to clue in stuck together. How many more do I have? Three? Three more. I think we'll get them all done. Example 2. Curling is great examples of conservation momentum. The only problem is, in real curling, all the masses are identical, and the masses then end up canceling from the equation, and you get boring answers. So I'm going to make up curling questions, but I'll often make the rocks different masses, which is bad curling, but funner physics. So, Brian, no, I already picked on Brian. Joel, what are they asking me to find in example 2? Magnitude and direction? Yeah? Can you read me the word after the? Sorry, can you read me the word after the? I mean, there's a sentence that says after the, and there's a word right after that. You say collision, there's a job for conservation momentum. Okay? Yes, Joel, that's good. I saw you writing. You said, oh, the sum of all the initial momentum equals the sum of all the final momentum. Joel, I see directions. What's the first direction that you see? Let's call that positive. You could call it negative, but when in doubt, I tend to call east positive. So, Joel, I'm going to put a positive there. Positive. Oh, positive here. Also positive. I guess here, the second stone is moving slowly, and the first stone rear ends it. Yes? Are there two rocks? Rock A, rock B. There's my organization. All right. Is there a collision? This is a job for conservation momentum. Joel, before the collision, what's moving? Rock A, rock B, both or neither? Rock A is moving, yes. Is rock B moving? So, rock A, rock B, both or neither? Before the collision, stuck together or separate? Before the collision, are they stuck together or are they separate? So, you ready? How fast is mass A moving? How fast is mass B moving? Can they be stuck together if they're moving? Say that, and you're way overcomplicating this, right? Okay. So, ready? Before the collision, what's moving? Mass A, mass B, both or neither? Stuck together or separate? So I'm going to have to write, I got the momentum of A initially to deal with and the momentum of B initially to deal with. If they were stuck together, I would write momentum both. But they're not. You okay with that? You sure? Wow, they collide! People on YouTube are loving me right now. After the collision, what's moving? Mass A, mass B, both or neither? Well, definitely the first stone, and it wants me to find the velocity of the second stone, so I think they both got to be moving. Because otherwise, if the second stone was at rest, that'd be a boring answer. I might get 0 as an answer, but I doubt it. So both moving, and I don't think they're stuck together. First of all, because curling rocks don't stick together. I've watched curling. And also, otherwise, I would know the velocity of the second stone. It would be 0.65, and the question's done. That's a stupid question. So I think, ready? After the collision, what's moving? Mass A, mass B, both or neither? Stuck together or separate? So I'm going to write this. Momentum A final. Emma, get ready. And momentum B final. Emma, momentum is what times what? Now, you may find as you get good at this that you can combine a couple of these steps, and then your homework, knock yourself out, go ahead and try. In our notes, Oliver, I'm being very meticulous, and I'd probably do it this way on a test. My next line, I would say, mass A, velocity A, initial. Mass B, velocity B, initial. Mass A, velocity A, final. Mass B, velocity B, final. Joel, what are we trying to find? Of what? Of what? What is the? It doesn't say what is the well, okay, so what are we trying to find? Which is, I guess, of the second stone? That. Here. I'll make it stand out. That's what I want to get by itself. How would I get that by itself? The left side drops down like a domino, yes? And then I think I minus that over. You know what? Let's write that. Let's write that right now. So it's going to be mass A, VA drops down like a domino, plus mass B, VB initial drops down like a domino. You just told me I'm going to subtract mass A and VA final, yes? Now that would have this by itself. How would I get the V by itself? What am I going to have to do with the little MB? Okay, can I do that in one step? I'm going to go divide by the mass of B. And Joel, if you're okay with it, I'm going to put the velocity of B final over here by itself because that's where we're used to seeing things. Is this very similar to some of the stuff we did with forces in terms of the equation solving? Different concept, but similar math, yes. And now we're at plug and chug time. Have I got more room? Yeah, I can move down a line. Joel, let's finish this off, you and I. We're doing great. So now, mass A, Mr. Duke, we're only doing great if you copy the question down right. Joel, what's the mass of object A? I've scrolled down. 18? What's the velocity? Be careful when you're telling me velocities of the positive and negative signs if we need to be. What's the velocity of object A initially? Sorry, I didn't hear. 2.6? Plus, what's the mass of object B? And its velocity? Yeah, that makes sense because the first rock ran into it, caught up to it, so it's going faster. Minus 18. What's the final velocity of rock A? It says. Sorry? Thank you. Same direction still? Yes? Okay. What if it had said change direction? Negative. Easy fix, but I just have to pay attention and catch it, which is why I keep writing the vector bars on here to remind myself, pay attention to direction, pay attention to direction. Divided by mass B, 12.5. Joel, is this a fraction? Yeah. Is there more than one thing on the top? Yeah. Brackets around the top. Don't need brackets around the bottom. What do you get? What do you get? Where's your calculator? Finally getting it out? Good. Huh? So 4.29. Anybody else? I'm not seeing any nods yet. I'm seeing a lot of people not typing anything in. Then you're just going to have more homework because I'm going to wait. Oliver's going to get his calculator out. See how it works? Sierra has hers out. What'd you get, Sierra? Read me what your screen says. Okay. Hannah, what'd you get? 4.00? 4.08? So 4.01 if we go to 3 sig figs and just round off to there? Anybody else? 4.01? 4.01? 4.01? Okay. Did it say magnitude and direction? Direction. Oh, okay. And I think I mentioned last time, but I'll repeat myself, replace curling rocks with cars, and now you have some of the tools that RCMP crime investigators are using when they're looking at car accidents. Oh, Joel, is this collision elastic or inelastic? Inelastic? They stuck together? So how do you remember? Elastic, rubber band, bounce apart. I don't like the terminology, but it's what's used in physics, so okay. I'll continue example 3 on Friday, but I'm going to give you most of the homework now. You can do everything. In example 3, we're just going to have a change in direction. How could I glance at example 3 so quickly and tell there's going to be a change in direction? I saw the word east, and I also saw the word... It is that Captain Obvious once you practice. And, I'll let one way be positive, usually east. I'll let one way be negative, usually west. And I'll go through. There is a collision. Wham, they collide. For now, if you want to get a start on the homework... I don't know why I have a blank page there, but I do. Okay. Number 1 isn't conservation momentum. That's still impulse and change in momentum. 2 is good. 3 is good. 4 is good. I'm going to assign the rest of these eventually, but if you just want to whittle away at this, you can. Some of you haven't done the take-home quiz yet. If you want to go further, you can.